All right, we're on day one, block 3 notes. We're going to look at what's called conditional statements. So for the block 3 section, there was another document called conditional statements list. You need that open in Cami as well. So if you look at the top here, I have two tabs open, so they're right next to each other. So you want this document open. We're going to add to it today. And this document will basically help us keep track of a bunch of definitions so you kind of have them all in one place. If you don't like having the multiple tabs, this one you might want to recreate just on scratch paper or print it if you can. It's kind of like a reference sheet. So we'll be looking at this exact same document a lot, especially this first week of the course. So you'll want to be able to access it easily. So going back to the block 3 notes. So let's start with conditional statements. I'm going to switch to the text tool on Cami so I can type a little bit here. So a conditional statement, it's an if-then statement that tells the relationship between a hypothesis and conclusion. So you might be more familiar with this in like the context of science class, right? Like if it's cloudy, then it will rain. That's a conditional statement. But we're going to look at them in terms of math and specifically geometry vocabulary. So a little bit more with that. A conditional statement is always true unless a true hypothesis leads to a false conclusion. Okay, so like if it's sunny out, then it will rain. That's not necessarily true. I guess sometimes, but not usually, right? So a couple other pieces here. So if then, sometimes they're represented with letters, P to Q. Don't worry too much about the letters. It's not like a variable, just oftentimes that's in relationship. So if that's our hypothesis, that's the P, then there's a conclusion. That's the Q statement. Okay, it says here the words if and then are not parts of the hypothesis or conclusion. They just kind of set it up. So let's start with a few examples. Rewrite the following as conditional statements. So it just says 18-year-olds are eligible to drive. So as a conditional statement, I need if and then. I need those two words. So we'll say if you are 18 years old, then you are eligible to drive. That's it. Number 2 is more geometry based. So an obtuse triangle has exactly one obtuse angle. So to make that a conditional statement, we'll say if a triangle has exactly one obtuse angle, then it is an obtuse triangle. Okay, our hypothesis, if it has exactly one obtuse angle, then we conclude it's an obtuse triangle. So those are our conditional statements. That's this first line here, if hypothesis, then conclusion. We also have the converse of that. So converse kind of means opposite. So the converse statement, if a conclusion, then the hypothesis. So switching the order, and we'll look at some of those in a moment. If both the conditional and its converse are true, then they're combined into a biconditional statement. So the setup of that goes hypothesis if and only if. This is our important phrase here, the conclusion. This phrasing, it doesn't really make sense in English terms. But what it means in the math world is that it works both directions, right? So we're going to look at more examples of this in a moment, so I know you might be a little confused. We'll get to examples in a second. Let's just go back to practicing regular conditional statements. So we have a few definitions. So for our notes sheet, whenever there's a star like this, that means we're going to add that vocabulary to our statement list. Okay, so I tried to put the stars in anywhere we'd add it to that statement list. So we have two things we're going to add: vertical angles and transitive property. Okay, so just to give you a quick definition of vertical angles before we write the conditional statement, they're opposite angles formed by intersecting lines. So for example, this angle and this angle are vertical angles, right? They're opposite each other. And then like this angle here and this one here are vertical angles. Okay, so let's go to our conditional statement list so that we can write that in our conditional statement setup. So we have an example. We already talked about congruent today. If it's the same measure, then congruent. Here's some geometry context. These are congruent segments, congruent angles, and then a couple of pictures. So our first one, I'm going to write vertical angles pretty small at the top here so that I remember that's what this vocab word is. And then our conditional statement. So we're going to say if vertical angles then congruent. Okay, that's our conditional statement. So what that means is, I'm going to switch back to the notes for a second. These are angles formed, we'll say opposite angles formed by intersecting lines and they're congruent. Okay, we'll use that actually a ton, this vertical angles, a ton, this geometry unit. So I'm going to draw the picture first. So again, if you hold shift, you can get nice straight lines. I'm going to put in some numbers. So let's go 1, 2, 3, and 4. So those are representing our angle measures. So we know angle 1 is congruent to angle 2 because they're vertical, opposite each other. Angle 3 is congruent to angle 4. Our other vocab word is transitive property. So transitive property basically says if there are two things equal to each other, equal to the same thing, then the third pieces are equal to each other. And that's a little bit confusing. So easier way to see that is with an example, and then we'll add it to our sheet. Actually, I'm going to add it to the sheet right away so we don't write it all twice. So let's go over to our statement sheet. I'm going to draw the picture first. Draw a straight line. I'm just recreating that picture you had. A, B, C, then D. So what the transitive property says, let's start in the middle with the context here. So let's say if segment AB is congruent to segment BC and segment BC is congruent to segment DC, then AB is congruent to DC. Right, so like see how the BC is repeated? Then you can kind of skip them. Well, that means AB is also equal to DC. Okay, so our conditional statement here, if X is congruent to Y, this is just like general terms, and Y is congruent to Z, then X is congruent or equal to Z. And this is our transitive property. Okay, we'll use this one a lot too. Right? So if one thing is equal to two different things, then you can kind of skip that middle piece, the y here, and just say x is equal to z. Okay. All right, so last thing here is we'll do a little bit more practice with those conditional statements. So we're going to write the conditional, the converse, and the biconditional. We talked about that a little bit earlier. I would use the text feature here, typing. It's a little bit easier than writing out all of these. So our first one, it says a right angle is an angle whose measure is equal to 90 degrees. So the conditional, we can say, if an angle measures 90 degrees, then it is a right angle. Okay? The converse would be going in the other direction. So we're going to start with the conclusion. So we'll say if an angle is a right angle, and then we'll end with the original hypothesis. Then it measures 90 degrees. So now, as long as both of these are true, which they are, the biconditional means we can go in both directions using only one statement. So this one we do not use if-then format. We're going to just start with, doesn't really matter, we're going to start with either hypothesis. I'm going to start with the first one. But instead of saying if, we're just going to say an angle is a right angle. And then I use the phrase if and only if it measures 90 degrees. It's kind of like putting them together. And this middle part, if and only if, I put in bold. That's what shows that it goes both ways. And then we'll do one more together here. So number 2, perpendicular lines are lines that intersect to form right angles. So our conditional, if lines intersect to form right angles, then they are perpendicular. Our converse is going the other way. If lines are perpendicular, then they intersect to form right angles. And then our biconditional puts them together. Lines are perpendicular if and only if, they intersect to form right angles. Okay, so I just want to point out that it's not like a guarantee that there's a biconditional statement, and we'll see some examples kind of throughout the next few lessons. One way to think of that, like if I said, if you are a student in this summer school class, then you are an incoming freshman. Okay, that's the conditional. If I reversed it and I say, if you are an incoming freshman, then you are a student in this summer school class, well, that's definitely not true because you guys are only a tiny portion of our incoming freshmen, and there's plenty of freshmen that are not in this class, right? So I cannot write it biconditional for that statement. Okay, so they're not always going to work. You can only write the biconditional if both conditional and the converse are true. Okay, so and then you'll have a practice worksheet to do more statements just like this.